Hello, today we're going to begin our study of triangles in this new chapter. And the first thing we need to be able to do is be able to classify triangles. So triangle, as you probably remember, is just a polygon with three sides. We can classify triangles or categorize them based off of what their sides are like and what their angles are like. So classifying triangles by sides is basically, do you have any sides that are congruent to each other? If no sides are congruent, it's scalene. If two sides are congruent, that's isosceles. See how we have those red marks indicating that these two sides are congruent. If all three sides are congruent, it is equilateral. We can also classify triangles by angles. If you have all three angles of the triangle being acute, we call that an acute triangle. It is a right triangle if we have one right angle. You'll never have more than one right angle in a triangle. It is an obtuse triangle if it has one obtuse angle. Same idea here, you can only have one obtuse angle in a triangle. Or if you have three congruent angles, it is an equiangular triangle. Equilateral and equiangular will happen at the same time if you ever see those. So for these problems here, we're going to classify a triangle by its sides and its angles. There's going to be two words to describe each of these. Let's take a look at the first one. So we see we have two congruent sides here, so there's two red tick marks. So this is isosceles. And then we have a right angle here, so it's an isosceles right triangle. The next one, we have three congruent sides, so it's equilateral. And any equilateral triangle is also equiangular. So this is equilateral, equiangular. Those are kind of weird looking words, but they're the words we use. We can't assume sides are the same length if they're not marked. So in number 5, none of the sides are marked as being congruent. That's what we call scalene. No sides are equal. And then notice that angle K here is an obtuse angle. So this one is in a scalene obtuse triangle. Last one, number 6 here. All of these angles here are acute. None of the sides are the same, so scalene. So this one's a scalene acute triangle. So we can tell these by just looking for the most part. We can also be given the coordinates for the three vertices of a triangle, and we can figure out what kind of triangle we are dealing with, at least based off of the side lengths and whether or not it's a right triangle if we have the coordinates for those three vertices. In order to do that, we need to use both the distance formula to find out the side lengths and the slope formula to see if any of the lines are perpendicular to each other. One quick reminder about perpendicular, which this is the symbol for that. If your two slopes multiply to -1, aka if they are opposite reciprocals, that makes them perpendicular. So that would be two lines that cross at right angles, meaning you'd end up with a right triangle, kind of like what you see here in number 3. So let's try some of those out. This is the most complicated things we'll be doing today. So they want us to classify the triangle by its sides and determine whether it's a right triangle. They give us coordinates, so the first thing we're going to do is put those coordinates in Desmos just so we get a good idea of what's going on. As always, I'm going to label those two just so I remember which point is which. And last but not least, C is 6,3. So we need to do two things here. We need to find the side lengths and see if any side lengths are the same. And we do that using the distance formula. So I'm going to start by finding the distance from A to B. When I'm using A and B, A is x1, y1, B is x2, y2, and we just plug things into the distance formula like so. So let's try that out. To get your square root symbol, just a friendly reminder, it's been a while since we've done this. It is right here next to your pi button. And then type in things exactly like you see them. x2 is -1 minus 0. And then your squared button is right here. Plus, parentheses, y2 is 2 minus 0, parentheses, squared once again. And we end up, we're going to round these to the nearest tenth. We get the AB is 2.2 when we round. And so then we'll use the same formula to find the length of BC and CA. So if I'm doing BC, oops, I labeled that wrong. I'm do the same thing but have a new x1 and y1, x2 and y2. So let's do that. So square root symbol, parentheses, x2 is 6, minus x1 is -1, so 6 minus -1, that double negative is important, squared, plus y2 is 3, minus y1 is 2, squared. And we get, if we round that to one decimal place, 7.1. So we know right now it's not equilateral because we have two different side lengths. Now let's do the last set of points. Let's do CA. So that means C is x1, y1 now, and A is x2, y2. So let's type that into Desmos with our distance formula. 0 is x2, minus x1 is 6. 0 is y2, minus y1 is 3. And I forgot my squareds here. I need a squared here and a squared here. When we do that, we get 6.7. So these are my three side lengths. This one is 2.2, this one is 7.1, this one is 6.7. Since they are all different, we say that this triangle is scalene. So we've taken care of classifying ABC by its sides. Now we need to see if it's a right angle. So the way we do that is we use our slope formula. And I'm going to use the things like I have labeled back here. So to find the slope of AB, I'm now going to use the slope formula, which is right here, but substitute in the appropriate x1 and y1 and x2 and y2. So I'm going to do that in Desmos as well. Our slope formula is a big fraction, so first start by typing in your division sign, which will make things look like a fraction. For A and B, y2 is 2, minus y1 is 0. x2 is -1, minus x1 is 0. And we get that the slope of AB is 2, -2, sorry, misspoke there. Now let's do the same thing for BC. So now using what I have labeled in green as x2 and x1 and y2 and y1. So here, again, type in your division sign first to get that fraction. This time y2 is 3 minus y1 is 2 over x2 is 6 minus x1 is -1. And I get, let's do two decimal places for slopes. We get 0.14. So we know that the angle between AB and BC is not a right angle because if I do -2 times 0.14, I do not get -1. It has to be -1 exactly. So now let's do the slope of CA. So now I'm using what I have labeled in orange. So in Desmos, I'm going to do my slope formula. y2 is 0, minus y1 is 3. x2 is 0, minus x1 is 6. And I get 0.5. 0.5 is the same as 1/2, if you remember that off the top of your head. And then we are going to end up with this being a right triangle because if I take the slope of AB and the slope of CA and multiply them, -2 times 0.5 or -2 times 1/2 is -1. So since -2 times -1/2 equals -1 exactly, that means we do have a right angle here. It is the angle between AB and CA. So this right here would be the right angle. And so we have a right triangle. So to answer our question completely, we would say that ABC is a scalene right triangle. So find the side lengths to figure out what type of triangle it is by sides, and then use the slopes. If you have two slopes that multiply together to -1, then it's a right triangle. If none of the slopes multiply together to -1, then it's not a right triangle. Let's try one more. So I'm going to get rid of all of this because we have a new A, B, and C. This time A is 0, 3. Helps if you put your comma in between there. B is 7, 1. And C is 1, -1. And so first thing we do, let's figure out our side lengths using the distance formula. So if I'm using the distance formula, I'm going to treat A as x1, y1, and B as x2, y2. So to find the length of AB, I'm going to put my distance formula in Desmos just like I did before. Square root, parentheses, x2 is 7, minus x1 is 0, squared, plus y2 is 1, minus y1 is 3, squared, and I get 7.3 if I round that to 1 decimal place. Now let's do the same thing for BC. So for BC, I'm going to make B x1, y1 and C x2, y2. Put my distance formula into Desmos. So square root, parentheses, x2 is 1 minus x1 is 7 squared, plus y2 is negative 1 minus y1 is 1 squared. And when I do that in rounded decimal place, 1 decimal place, I get that BC is 6.3. Now the last thing I'm going to do is I'm going to find the distance from C to A. So I'm going to treat C as x1, y1, A as x2, y2, and now put that distance formula into Desmos. So we have x2 is 0, minus x1 is 1 squared, plus y2 is 0, minus y1 is negative 1 squared, and we get 4.1. Once again, these are all 3 different sides. None of the sides are congruent. So we would call this a scalene triangle. So we've taken care of the scalene part. Now we need to check our slopes and see if any of our sides are perpendicular. If the slopes multiply to -1 for any 2 sides, then we are dealing with a right triangle. If that's not the case, then we are not. So now let's find the slope of AB. And again, I'm going to do that all into Desmos. We're back to our slope formula, so hit your division key first to get your fraction. If we're using AB, y2 is 1, minus y1 is 0, or sorry, 3, I misspoke. x2 is 7, minus x1 is 0. And if I round that to 2 decimal places, I get negative 0.29. Now let's try the next one. The next thing we are finding is the slope of BC. So once again, we'll just do that all in Desmos. Division sign to get your fraction set up. For BC, y2 is -1, minus y1 is 1, over x2 is 1, minus x1 is 6. I'm sorry, 7. Typed in the wrong number there. And I get 0.33. If I multiply these together, I will not get exactly -1. So far, we do not have a right angle. We still need to find the slope of the third side, CA, to see if this is a right triangle or not. So now using C and A as my x2 and x1 and y2 and y1. y2 is 3, minus y1 is -1, over x2 is 0, minus x1 is 1, and I get -4. And so then, -4. You can probably see right now that none of those multiply to -1, but let's just double check things here. I'm going to multiply my slopes together. -0.29 times 0.33 is not -1. -0.33 times -4 is not -1. It has to be exactly -1. And then -0.29 times -4 is also not -1. So since none of those multiply together,